my dear students. Let us start the study of upthrust and Archimedes principle part 2. Today in this, the topic is relative density and its measurement by Archimedes principle. We are going to learn about density, temperature effect on density, relative density, then relation between density and relative density, the difference between them, and then we will determine the relative density of a solid and a liquid substance by using Archimedes principle. So let us first understand the definition of density. Density of a substance is its mass per unit volume. Look at the figure. In this figure, one container has very less number of particles represented by green circles, whereas the second container has large number of green colored particles. So we can say that the mass of the particles in the first container is less as compared to the second container. Since the volume is same for both, so we say that density of the first container is less as compared to the density of second container. Thus, in simpler words, for a given volume, how much compactly a particle, a substance is having its mass, that decides its density. More compact means more dense. The SI unit of density is kg meter inverse cube. CGS unit of density is gram centimeter inverse cube. What is the relation between the two? 1 kg meter inverse cube is 1 upon 1000 gram centimeter inverse cube. Let us see the effect of temperature on density. Density of most of the substance decreases with increase in temperature. The reason is that when the substance is heated, the particles of the substance constituting its mass, they start moving randomly with more force, with more kinetic energy, due to which they go out of that given volume. And thus we see that mass of the substance in the given volume reduces. As you can see, and when the mass reduces for the same volume, density also reduces, it decreases with increase in temperature. And when you are cooling that substance, cooling, that means the mass container or the given volume will have more mass present in it. It will become more compact. When it becomes more compact, its density increases. You see this example. In this first, if the bottle has a deflated balloon and it is kept in normal temperature water, particles of, let us say, air are present, are shown with black dots inside the bottle. In the second container, the water is heated up. So the heat is transferred to the bottle also, and then to the mass of air present inside the bottle. The air starts expanding, and this expanded air goes into the balloon and the balloon inflates. What happens to the density of air inside the bottle? Since the mass decreases, density also decreases. There is only one exception in this. It is water. We have other exceptions also, but we will study mainly about water. You can find that water shows an uneven expansion. When it is cooled from a high temperature to 4 degrees Celsius, its density increases. But when it is cooled further from 4 degrees Celsius to 0 degrees Celsius, instead of becoming more compact, it expands. Its density decreases. This behavior of water is called anomalous expansion of water. So we can see that density of water is maximum at 4 degrees Celsius, that is equal to 1 gram per centimeter cube or 1000 kg per meter cube. Let us study about relative density. Children, as the name suggests, we are finding the density of a substance in comparison to any standard value. And that standard value is the density of water. So we will compare the density of the given substance with density of water at 4 degrees Celsius. Since it is a unit value, so it is very easy to compare. Density of water at 4 degrees Celsius is 1 gram per centimeter cube. So relative density is the ratio of the density of the substance to density of water at 4 degrees Celsius. It is also defined as ratio of mass of the substance to mass of an equal volume of water at 4 degrees Celsius. That is, if you consider the mass of that substance in a unit volume and mass of water in the same unit volume, then we can take density, relative density, as a ratio of mass of certain volume of the substance denoted by M1 and mass of equal unit volume of water at 4 degrees Celsius. That means for the same volumes, density will be compared. And relative density has no unit because it is a ratio of two similar physical quantities. Now, if relative density of an object is greater than 1, then the object sinks. And in water we are talking, and the relative density is less than 1, then the object floats. Because in that case, less than 1 density means the density of the substance is less and density of water is more. So when the numerator is less and denominator is more, in that case relative density will be less than 1. And when the relative density is greater than 1, why? Because the density of the object will be more and density of water will be less in comparison to that of the substance. Relative density is constant when pressure and temperature are constant. If pressure and temperature change, relative density will also change. Why? Because we know that density of a substance changes under pressure and temperature. We just studied that temperature increases, density of the substance decreases. So relative density also get affected. Now, let us study relationship between density and relative density. If relative density is given, how can you find out the value for density of a substance? So what is the relation between density and relative density? You know that in CGS system, density of water is 1 gram per centimeter cube. So we substitute the value in the formula 1.0 gram per centimeter cube. Relative density is equal to density of the substance in gram per centimeter cube upon density of water at 4 degrees Celsius. So from here we get relative density is equal to numerical value of density in gram per centimeter cube. Density of the substance is taken in gram per centimeter cube. Water's value is also in gram per centimeter cube. So whatever will be the density of the substance, whatever will be the number. Suppose density of the substance is 13.6 gram per centimeter cube, which is for mercury. So in that case, what will be the relative density of the substance? Relative density of the substance will be 13.6 because we will divide it with density of water in CGS system, that is 1 gram per centimeter cube. And in SI system, what we will find, we will write the density of the substance in kg per meter cube upon density of water at 4 degrees Celsius in kg per meter cube, which is 1000. So relative density will be numerical value of density of the substance into 10 power 3. For example, if we write that density of density in SI system is 10.8 into 10 power 3 kg per meter cube for silver. It is 10.8. Then what will be the relative density? Relative density will be 10.8 into 10 power 3. Now let us find out the difference between density and relative density. Density is mass per unit volume. Relative density is the ratio. Formula for density and formula for relative density. Then density has unit in CGS and SI system also, whereas relative density has no unit. Then we will study determination of relative density of a solid substance using Archimedes principle. I hope you remember Archimedes principle. What does it say? Archimedes principle states that when a body is immersed partially or completely in a liquid, it experiences an upthrust which is equal to the weight of the liquid displaced by the body. So let us study the relative density of a solid using this. Relative density in this case will be equal to weight of the solid in air upon apparent loss of weight of the solid in water. Let us understand it. Here we will do an activity to understand, to find the relative density of a solid using Archimedes principle. So first of all, we have taken a physical balance. One right pan is empty and in the left pan we have tied a stone with the help of a string. Then when some weight, some known quantity of mass is kept on the right pan, in that case we found that weight of the solid in air is W1. Let us say, for example, the weight of the solid in air is W1. Now next you have to keep this, keep a container, a flask with water in it on the left pan and dip the stone inside water. Now place weights on the right hand pan and find out the weight of the solid, weight of the stone. We found that the weight of the stone is W2, where W2 is less than W1. It was found that W2 is less than W1. Reason, because when the solid is in water, it is experiencing an upthrust, and thus we do not find its actual weight, we find its apparent weight. So how much is the loss in weight of the solid, of the stone? It is W1 minus W2, weight of the stone in air minus weight of the stone in water. And this only is equal to the upward force or the buoyant force acting on the object. Then what will be the relative density? Relative density is equal to weight of the object in air upon the apparent loss of weight of the solid. So that is W1 over W1 minus W2. Here we are going to understand that why relative density is equal to W1 upon W2, because you have the formula relative density is equal to mass of the body upon mass of water displaced by the body. Now mass multiplied by gravity will give you weight. So we can write that as weight of the body upon weight of water displaced by the body. So how much is the water displaced by the body? The water displaced by the body is equal to, is considered as the loss in weight of the body, or it is considered as upthrust according to Archimedes principle. Therefore, we consider relative density is equal to weight of body upon loss in weight of body in water. That is difference of the weight of the body in air minus difference of weight of the body in water, which is called apparent loss of weight. So this is how relative density is determined using Archimedes principle. Let us see an example where we have density of water given as 1000 kg per meter cube. Density of silver is given as 10500 kg per meter cube. So what will be the relative density of silver? It will come out to be 10.5. Now let us find out determination of relative density of a liquid substance by Archimedes principle. So how to measure the relative density of a liquid by Archimedes principle? Before this, earlier we found the relative density of a solid denser than water, and the solid was insoluble in water. If the solid is soluble in water, then instead of water, we take a liquid of known relative density in which the solid is insoluble and it sinks in that liquid. Then the process which we have described, it is repeated and the formula becomes relative density is equal to weight of the solid in air upon loss in weight of the solid in liquid, that liquid which we considered, into relative density of the liquid. Now for a liquid substance, if we want to find its relative density, first we will consider relative density as weight of the given volume of the liquid upon weight of the same volume of water. Then the solid will be immersed in liquid or water and we will find out how much water it has displaced. A solid will be immersed, any solid you can consider. So we will have relative density is equal to weight of the liquid displaced by the body. Actually, same body, you will first dip in the liquid whose density we are finding out, and then the same body you will dip in water. And then we will come to know the loss in weight of that body in the liquid whose density you have to find out, and loss in weight of the body in water, and that is written as weight of the body in air minus weight of the body in liquid upon weight of the body in air minus weight of the body in water. See, this is the procedure which we are going to use with spring balance, a Eureka can, and then first you will keep the container filled with the liquid whose relative density you have to find out, and then follow this procedure. Find the weight of the solid in air, then weight of the solid in the liquid. Similarly, you will repeat this procedure for water. You will fill the container with water and find out how much liquid, how much water the body displaces. So you will here get to know the loss of weight of the body in that liquid and loss of weight of the body in water. So if then to find the relative density of the liquid, we generally take a body which is heavier than both the given liquid and water and is also insoluble in both. So in this case, if we consider the weight of the body in air as W1 GF and weight of the liquid as W2 GF, then in water, the weight of the body is W3 GF. What I'm saying is weight of the body in air is W1 GF, in liquid is W2 GF, and in water is W3 GF. Then how to find the loss in weight? It is equal to W1 minus W2, loss in weight. Weight of the body in air, weight of the body in liquid, upon W1 minus W3, loss of weight in water, that is weight of the body in air minus weight of the body in water. So relative density of the liquid is obtained by this formula. Children, I hope it is clear to you. Thank you.